So another hypothesis regarding the origin of life I've come across this hypothesis probably a few months ago. So this hypothesis was made by Jeremy England, who is a physicist, or a biophysicist to be precise, at MIT, and his theory about, or his hypothesis is that life is just an inevitable result of the laws of physics, or the laws of thermodynamics, the laws of the second law of thermodynamics to be exact. And he says that the main goal of life is just to facilitate the second law of thermodynamics. So just to give an idea of what the second law of thermodynamics is, that it says that entropy in a system increases over time, and this system can be is generally an isolated system, and in this case we are talking about the universe as a system, and the universe as a whole as one system. So the entropy of the universe as a whole will increase over time, and living things, including me and every other living thing in this planet, you included, are just to increase the entropy of this universe. Now, what is entropy and what is the second law of thermodynamics? Okay, the second law of thermodynamics is about the increasing of entropy over time, and entropy is the rate of disorder, or the amount of disorder in a system. Now, before I move forward, I'll have to explain what entropy is. So for an isolated system, its natural tendency is to increase its entropy over time until it reaches its maximum entropy. So it is a natural tendency of an isolated system to increase its entropy. Now, if you want to decrease the entropy of a system, we have to apply external energy. Only then we can decrease the entropy of a system. Now, everything that I'm speaking is very abstract in nature, so I will have to give an example, a practical example that one can understand. So one very easy example to understand why disorder increases over time. So increasing of entropy over time means increasing of disorder over time. So why disorder increases? Take a very simple example. This is the simplest example that I could come up with. So suppose take a plate. This is a very simple drawing. So suppose this big rectangle is one plate, and there are two different types of peels. One is circular and the other is rectangular. Here you can see that they are in a ordered state. The circular ones are on one side, the rectangular ones are on other side. Now if I shuffle this, obviously since it is a drawing, nothing is going to happen, but suppose consider this is as a real thing, a real plate. If I shuffle it, what will happen is that it will get randomly distributed. Some circular peels will get mixed up with the rectangular ones. Some rectangular ones will get mixed up with the circular ones. As a result, you will get that there is you can see the disorderedness in this system. Now, if I want to reconfigure it, or that means if I want to again separate out the circular peels from the rectangular ones, I will have to apply external energy. By external energy, I mean that I'll have to manually pick up the circular ones and separate it from the rectangular ones. So it will require an external energy from me, because I'm not in this part of not a part of this isolated system. So from your intuition, you can figure out that why the randomness or this disorder occurs, because there are so suppose this is one possible configuration. So statistically speaking, there are many more configurations which are in disordered state as compared to the number of configurations that are in ordered state. So since there are more disordered states than there are ordered states, so intuitively you can say that, or you can figure out that over time things will get more disordered, because it's 1/4. And if I take 3 coins, then the probability is 1/8. So you can see that by increasing one one coin, I have decreased the probability of. So as I increase the number of coins, so the probability that when I suppose if I take 10 coins, the probability that when I toss all the 10 coins at a time, then the probability that all the 10 coins will come up heads at the same time is going to be very less. So it is more likely that the result will be more random in nature. So this kind of intuition, through this kind of intuition, you can figure out that with time these pills will get more random rather than more organized. So now coming back to the big picture of this universe. So with time everything is getting more and more random as per the second law of thermodynamics. But the exceptions of that second law of thermodynamics are things like life itself. So you can see that life, which means organisms, animals and plants, me and you, we are all very complex organisms, and we are all very organized organisms, organized collection of atoms and molecules and cells. So this organization definitely required energy, external energy, so which is in a sense counterintuitive. If the second law of thermodynamics, if the universe is following the second law of thermodynamics, which means that randomness should be increasing over time, then why is there life at all? Because life means that entropy is decreasing, which should not be the case. Entropy should be increasing. But the fact that life exists in this universe, at least on one planet so far, means that definitely, and with time, organisms are only getting more and more complex. So as a result, entropy is decreasing, order is being created, because yes, definitely, if I'm not just, suppose take my example, I'm not just any just a random configuration of atoms and molecules. Only a specific or only a certain configuration of atoms and molecules can create an intelligent organism like me. Hopefully I'm intelligent. Yes, anyway. So why is this so? Why is there this counterintuitive thing going on in this universe? Why is there life at all? So that is what Jeremy England's hypothesis says there. So basically in the short term you can see there's counterintuitive phenomenon occurring in this universe, which is life. But what he says that this complex organization of molecules that we call life can actually help absorb and dissipate energy more efficiently. So what he is saying in simple terms is that living organisms are a very efficient way of creating entropy or creating disorder. So in the big picture of life, we are doing nothing but increasing the entropy or increasing the disorder of the universe. But in the short term, we can see this illusion that, as per Jeremy England, in the short term, there are a little bit of order through which life arises, but at the same time, this order is, the higher purpose of this order is just to increase more disorder. But in the short term, you can see this order, which you call life, being created. But the big picture, in the long term, its purpose is to just create more disorder in a more efficient way. So that is what so basically that is what he is saying. So I don't know how true it is. I've been looking through his work, and maybe it is still not being conclusively proven that this is the ultimate theory of life or the ultimate explanation about the origin of life. But so far what I've seen, he has been able to prove a lot of his claims that he's been making. So anyways, this is a very interesting way of looking at life, but at the same time it is not yet been proved that this is the actual reason why life exists, or whether increasing the entropy of the universe is the only purpose of life. Who knows?